going to be a short presentation on the RNA-seq pipeline comparison program. And it's just going to give you an idea of how to run it and how it works and stuff like that. So it's going to be several things, but first, just want to start the workflow. Essentially, how it works is as the files come in, the idea behind the comparison program is to compare the output files from two different pipelines of the RNA-seq, bulk RNA-seq, but from two different platforms. So even though we use the same applications and programs to do the comparisons, to do the actual quality control and the sequencing, one comes from DNA Nexus, and the other one comes from what we call Cromwell on Azure, which is our new platform and workflow that we're going to be using. So the idea is that we're taking the outputs from both of those workflows and comparing them to see if we have the exact same results. So it's going to first compare the stats, the trimmer outputs for both of the workflows, and notating any differences if there are any, and then moving on to what we call our BAM files, and notating any differences there to see if they match. Some of the files, output files, like this gene results file, we don't need all of the features and columns in it, so we need to create a subset of the data. And at certain steps, will be a file conversion step. For example, this gene results file, we only need the TPM counts and expected counts and so forth. So we're going to create a subset of that and then move that down, and then that's actually going to get compared. And again, seeing if there's any differences there, and then moving on to expected counts, noting any differences there. Here we have another file conversion as we move up to what we call our Star Fusion and Ariba comparison, noting any differences there. And then onto our metrics. There's several different metrics files. We decided to use one of the metrics quality control files to match them. And then the last one is a merged file comparison. At the end of it, there will be an outputs file to notate any and all differences if there are any. And that's essentially how the workflow is. The instructions of how to first run the program is you have to first clone this repo, and then we're onto whatever workstation that you're using, where it's locally, or if you're using an IDE, such as Visual Studio, or if you're working on a VM, or if you're working on a cloud PC, as many of us do, you first have to clone the repo, provide the path for all of the input files, which we're going to go over. Step 2 is to convert all the Python files into executable files. Mostly the Python programs that actually run. The best way to do that is to whatever program name that it is, you're going to prefix it with chmod 777, and that will turn it into an executable file. And then running the command itself, it's going to be basically a bash script that's going to run everything. And then you're going to have to put in the appropriate sample name. This is just a generic name I put in here. Obviously, it's not going to reflect the name that you're going to give it. And then you can view the results in an output folder, which we'll see in a little bit later. So now, if we go to my cloud PC here, we can actually see the results, or actually how this is working. Essentially, how it's going to work is through the bash command script. This script right here. So essentially, how it's going to run is it's going to take the input files from the wherever file extension or file path that you have them saved in, or have you whatever files that you have saved in the inputs section folder, and then it's going to run. Here's where it is actually running the program in this line here. and then putting all the outputs in the outputs folder, and then whatever name, this name will be unique to whichever name you get. It's more convention to put whatever sample file that you're running. This one here is SL430702. Obviously, yours will probably differ. And then there's intermediate files that are created, sub files and stuff like that. So it's important that rather than have these files build up, we remove all of the files, and that's what these commands do here. This program is set up to run the sample one after another. So after you get after you want to compare one sample file, maybe you want to compare another one right after without any necessary intervention. So you're going to have another pathway, and then again to the appropriate input file that you have, and then again it's going to run the program, again putting a unique name for your results, removing all the files, and then if you want to run another file after that, compare another set of output files, you can just again get the necessary files and then put them in the inputs file and stuff like that to run over again. And you can have as many of these set up as you want. I have 4 set up. Each set of 4 lines is one comparison program, or one comparison epoch, I guess you can say, or set, followed by another one, followed by the next, followed by the next, followed by the next. And if we go over to so that script, this script here will run this program. That in turn is running all of these scripts. So here, all comparison programs are actually running. And here is where all of the input data goes. Again, this is going to be very esoteric and relative to where your input files are being stored. And the outputs will go into the outputs folder here. As you can see, I ran a couple samples already, and these is what you'll get, a report that gets printed out. It's pretty self-explanatory. It's just going to tell you, for example, the trim reads, the number of trim reads that there are, and the number of bases, number of reads, and the bases from any one of the reads. And if there's a difference, it'll notate it. If there's no difference, it will obviously say it, and that will be pretty much the same for every one of the steps here. This is the BAM file. This is the transcriptome BAM file. TPM differences, genes expected counts, and so forth. Gene star infusions report and everything like that. And that's pretty much it. I just wanted to go through that with you. And this concludes this presentation. Thank you.